Hello, everybody. Welcome back to Shit You Wish Your Building Did. This is the podcast where technology experts tell you how to make your building smarter. Today, we're speaking to Craig Stevenson from Auros Group and Rob Murchison from Intelligent Buildings. What is the power of existing buildings? New buildings are sexy, but few realize the value in existing buildings and how easy it is to get low energy consumption through retrofits. So stick around for this important conversation with Craig and Rob. And if you like what you hear, don't forget to like the episode. And if you subscribe to our channel, you'll be notified when we publish new content. Let's go. Welcome everybody to the podcast. And of course, welcome Craig and Rob. Really pleased you two could come and join me for this show. So let's just kick it off. Let's start with a little bit of introduction. Maybe Craig, you could explain first your company and where you come from.
Absolutely. So first of all, Jim, thanks for hosting us today. We're real excited to be here and talk shop about building performance. So my name is Craig Stevenson. I'm the president of the Auros Group. We founded the Auros Group to really operate at the intersection of building science and data science. And we believe to operate our buildings over the life cycle of the buildings, we need to use both building science and data science to achieve those goals. And that's really where our business is focused.
Great. Rob?
Hey, Jim. Thanks. Like Craig said, thanks for having us on here. I'm Rob Murchison, principal at Intelligent Buildings, and our vision is to intelligently impact the world's built environment. And in the past 2 decades, while we've been on that journey to do that, the decarbonization has become a real topic. And what we hope to inspire commercial building owners to do in this conversation today is that there is a path to decarbonization. It doesn't have to be that painful. If you start with connecting your buildings in a way so you can start to gather data and have fact-based decisions. So look forward to having this conversation.
Yeah, exactly. And I think you framed that really well. And I think what really got me interested in having this discussion with you guys was, I know the book, Craig, that you wrote not a little while back, but great one about the power of existing buildings. And I think a lot of us in the industry know that existing buildings are going to form a massive part of the future of decarbonization in the built environment. So, I mean, with that in mind, I think my first question to you guys is, where do existing building owners start with retrofit? And Craig, I know you want to tackle that first.
Sure. So thank you for mentioning the book. The book was a bit of inspiration. When we started to get into the decarbonization space, we realized really, really quickly that we're not going to build our way out of our problem with new construction, which is too expensive. It's never going to happen. And similarly, we're not going to renewable our way out of climate change, right? Renewables are going to play a key role in how we get there, but they have a role to play, and we cannot ignore efficiency, and that's really got to be the first step. So when we get involved in any project, building owner that wants to talk about either meeting a specific goal, whether it be voluntary or regulatory, the first things we need to really do is align around what those goals are. That's the most critical step, because that energizes everything from selection of your project team to how you go about reaching those goals. So for us, the very first step has to be setting the goals for how we're going to achieve this. And if you think about that for a half a second, there's a common thread through the process, and the common thread is always metrics. And that's why I think that we have a relationship with Rob and Intelligent Buildings, because these guys are talking about smart buildings. And it's like, well, wait a second. If I have a smart building that's giving me feedback loops, I want those feedback loops to connect to the goals that I'm setting, which are going to connect to the design standards that we're going to achieve and design, and then ultimately how that building's going to operate. So that's the common thread that cuts through everything. And that's why I think talking to the data science community or firms like Intelligent Buildings that understand how to set up our meters and sensors and democratize our data is so important for building scientists like us.
Yeah, exactly. You can't manage what you don't measure, right? So we need that data.
Right.
Rob, what are your thoughts on where building owners can start with retrofit?
Well, I think as Craig said, you have to start with a goal. What we like to draw an analogy, if you will, when we talk about existing buildings to lifestyles, right, of humans. And if you set out to have a healthier lifestyle, you sort of got a baseline where you are. You got to assess where you are or where you want to go. And to Craig's point, I mean, setting those goals based on the region of the world that you sit in and your organizational goals. Once you have that, you have to sort of, like I said earlier, it's not that hard. It can be daunting if you don't put a plan together. But you can start by getting insights around your primary energy sources in the building. And as Craig will allude to through this podcast, that you have the ability then to use that data to make better decisions. And I think that's the key point here, is to go to the data and drive the decisions so that all your stakeholders, it's a complex group of stakeholders when you come to existing buildings, can align around the same goal.
Mm-hmm. I love that analogy, Rob. I mean, it's like conservation with sacrifice is so 1970s. And, for where we're at now in the world, we can decarbonize a building and make our buildings reach our thermal comfort criteria, give us all the qualities of high performance relative to light and sound and everything else we want from our buildings. We don't need to shut things off and sacrifice to reach our decarbonization goals. So this idea of building healthness, right? The building assessment, to understand it, it's not just about weight, it's about BMI, exercise, nutrition, everything that goes into human assessment. The same thing we look at when we look at buildings assessments is we look and say it's not just a matter about consumption of energy. It's more than that, right? It's about how the building operates. We build buildings to use buildings. They cannot not meet that purpose, or we're missing it altogether. So how do we build a building that gives us everything we want? And we believe that the right process for that really starts with the envelope, because it reduces loads, it keeps the outside out, the inside in, it gets at everything we want to get at. So fundamentally and foundationally, that's where we start.
Okay, and that's perfect, because that was going to be my next question, right, about the natural order of sustainability. And so you mentioned the building envelope, and you described that as passive first, right?
We do.
Okay, and then so you start with that, maybe dig into that a little bit. What about the building envelope, and then what comes
Absolutely.
after that?
So if we ask your audience, what is the cheapest form of energy, right? We're probably going to get a couple different answers from that. And for us, it's always going to be one answer is always the same answer. It's the energy we never use.
Sure.
And that's where we have to start, right? If we just talk about using an alternative source of energy, then we're really not attacking the efficiency problem, which is where I believe all the value in a building is at. And the only way you can get at that value is to reduce your loads. Well, what's the only way to reduce our loads, right? I've got to create an envelope that has a climate-specific thermal barrier and air barrier that's going to keep the outside out. So there is building science out there right now that supports that. The energy modeling supports that, and there's building science like, Passive House Institute, for example, that represents a building science approach to this, where they're defining where that inflection point on that envelope is, right? So I'm out of Pittsburgh, Pennsylvania, and our code is right around an R18 for our envelope. And, if I want to get to passive house levels of performance, climate specific performances, you're going to be around an R30 or 35. But then I can go to an R400 and it's not going to make a bit of difference, right? I want to know where that inflection point is worldwide, any climate zone. That's a definition, that's a building science definition. And once I achieve that, then all I have to do is everything else is I got to connect it, right? I've got to mitigate my thermal bridging, and I got to make sure that my envelope is sound. It's like this. If I put hot coffee into here and I put a lid on it, 2 days later I take the lid off and steam comes out. Why does steam come out? Because the energy has nowhere else to go. That's as simple as I can say in terms of the energy in a building. We don't want to pressurize our building through terrible air leaky envelopes and rebuy our heating and cooling all over again. We want to buy it once, keep it in the building, and then reuse it, as long as we don't sacrifice our ventilation for air quality and we don't sacrifice other building parameters for performance. So this concept of the natural order of sustainability, we always say, if you violate the natural order of sustainability, you're going to pay a premium. Well, what is it? It's passive first, reduce our loads, active seconds, right size our equipment, mostly decouple our equipment. Ventilation and heating and cooling become different sources now because I don't need a big box on my roof anymore. And then renewables last because I want my PV array to be this big and not this big.
And if I can just jump in there, Jim, I think in drawing the analogy, because I mean, as you can see, I mean, Craig knows his stuff, and there's a lot of terminology and concepts to get your head around here. So as being more of the slow guy in the room here, Craig and I have been working together for a while. I would say that going back to the analogy, if you're going to have a healthier lifestyle, you can't just eat all you want and exercise it away, right? You have to be able to do things better physically. So call it the outside infrastructure, the envelope that Craig's talking about, and then you need to also look at how you mentally go about your lifestyle. And I think someone with an organization called Intelligent Buildings, right? With been helping lots of portfolio owners for 2 decades get smarter. Getting smarter involves both the technology stuff in the building and the physical stuff on the outside of the building. And you're going to have to do both to decarbonize, because I think Craig's taught me, and you hold me to this stat, that only about 2%, 1.5% of buildings are getting retrofitted every year. And if we don't tackle this holistically in a way on existing buildings, we're never going to hit. We got individual country goals, but even the global goals that the UN and so forth talks about.
Yeah, there are well-known stats out there for sure. 80% of the buildings that will be standing in 2050 exist today. Buildings use 47% of the energy, at least in the United States, which is by far one of the biggest contributors to greenhouse gas emissions. And what I love about Rob is his humility, right? So I am not the smartest guy in the room when it comes to the data science, but I know what I want from a building. And I need guys like Rob, who are the smartest guys in the room when it comes to the data science, to work with me to say, okay, I can get, I love when I talk to an MEP and you want to talk about smart building infrastructure and they get excited. Next thing you know, $3 million later, I've got a smart building. But is it telling me what I wanted to tell me, right? And you work with a guy like Rob, and Rob's like, well, wait a second. I don't need to tell you what's coming out of every outlet in the building. If we're setting whole building performance targets for climate change, then how do I answer that question? And that's where we can work with Rob and say, okay, here's our goal. Help me create a use case on how I get the technology in a building to give me a feedback loop on that use case. That's why building science and data science have to come together. So while I have some experience in the building science side of this, and I know enough to be really dangerous on the data science side of this, I need the data science community to understand what we're doing so we can set our goals and we can get the feedback loops we need from our buildings.
Yeah. No, I mean, it's great. And I think, putting it like in, and I know this, you cover this in the book as well, but this natural order, I think it is very simple, simply laid out. And I think that's important because, I think some people miss that first step. They miss that passive step. They kind of, in our world, Rob, you're in our world, the smart kind of building world, like that sometimes get lost. I think people focus on the technology as opposed to like thinking about it in broader context.
So Jim, it solves way more problems, I think, than just being a simple step forward. Think about it from a volatility perspective. If I've got a building built to code-based standards and it has a performance rating that's up here, and I build a building to these energy levels that we're talking about down to here, the volatility is removed from the equation, right? We're talking about a trend line that looks like this as opposed to one that looks like this. So when you start getting into the data science using fault detection and diagnostics to manage energy operations, you're talking about in these buildings that we're building at these levels of performance, your volatility goes away. Right? We don't need to go over to our thermostat and go doink, 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 I'm too hot or too cold, change it. We're dealing with low flow, low load environments, right? The temperature creep in these buildings, and it's well documented, is literally if I turn the power off in a passive house building and I wait 2 weeks, the temperature will change 2 degrees over 2 weeks. So
Wow.
you're talking about a resilient building as well, which gets at, again, the envelope first approach gets at so much more than just energy. It gets at thermal comfort, it gets at resiliency, and gets at everything else. So it really is the foundation of how we get at these climate change goals.
Rob, did you want to?
Yeah, I was going to say, and just to sort of make this real, and Craig, you hold me to these numbers. But if you're talking about an existing building, when we get to the goal setting, right? Ultimately, we're going to have to get that building's EUI down into the low 20s on BTUs, thousands of BTUs per square foot. If you don't go about this passive first approach, you can get an initial hit, but then you're going to hit a proverbial brick wall in a building, right? You're going to hit a brick wall because you haven't reduced the load. So I think an incremental approach of just looking at one portion of the data science or the renewable energy, the on-site or off-site renewable energy, or just looking at the building envelope, looking at those siloed approaches isn't going to get us there. And by getting data from the beginning and then using that to inform a holistic view of and prioritizing it through, and Craig, you can talk a little bit about this simulation. You can prioritize all your investments and you can then put a whole plan together over the next decade. But you can't just say, I'm going to do this, I'm going to do this, I'm going to do this. We won't get there and you waste a lot of money.
Well, that's exactly right, Rob. I mean, when you sit back and you look at it, we're the only industry in the free world that will invest $150 million into an asset and not have a clue how it's supposed to perform, right? Because we build the code-based criteria. That's nuts. You look at every other industry in the free world, they're modeling at 6 decimals before they make a single investment to anything they're doing. So the problem we have with where we've been, right? History has taught us where we're at today, is that we use incrementalism to try to address the problem of climate change, right? Let's go into our building, replace all our LEDs. Okay, that didn't work. Let's replace our variable frequency drives. And we call it poking and hoping, right? We poke and hope our way to somewhere that we don't know where we're going, yet every other industry in the free world is modeling their way to that. So what we talk about in our book is, what we've been taught in the past of how we go about building efficiency is we start at code and we start working our way down. And we get to, say, a 30% improvement. We're like, wow, we feel really good, and we're good, but we're nowhere near our climate change goals. We have to flip that paradigm upside down and say, what is the most efficient building I can build? And why am I not building to that building, right? Because there has to be life cycle cost reasons and things like that, or first cost reasons. But we started there, and then we start working our way up until we hit a financial model that works for our client. And if you do it that way, in terms of what Rob was saying, this EUI is energy use intensity. So site, we measure buildings with different metrics. One of them is a site energy use intensity, which takes all the energy that comes into a building, converts it to a BTU, and we measure that by KBTU per square foot per year. And the question there becomes, if I build a building to code, and I look at my site EUI, if it's a commercial building in, say, North America, it might be around an 80 or 90 KBTU per square foot per year. If you build it to PASFOS levels of performance, you're at a 14. That's a 75% improvement in energy consumption right there alone. What we want to do is we want to always look at the whole building performance. Now, there is phasing, that's reasonable, because in an existing building, we have to respect life cycle. We have to respect our natural triggers. No one's going to rip out brand new windows in a building. It's just not reasonable. No one's going to whip out technology in a building that's not at its life cycle. So we have to, in an existing building, it's creating that whole building plan, which you can only do with a model because buildings are far too complex to do it with rule of thumb. And then we have to look at our triggers. And we have to say to ourselves, can I give myself a phasing plan over a period of time that I can reach that whole building performance goal? And the answer is yes, we do it all the time. But you can't build a code. That's the definition of insanity. I go through a renovation on a floor of one of my buildings. I replace it with code-based construction, and I expect this building to somehow transform. I mean, that's not logical. No. So what we do is we create a whole building plan meeting the PASFOS Interfit status if it's an existing building. And then as we go through and we look at our triggers, we're always using that context of how to meet that goal. That's the only way to do it. And then to give owners trust and de-risk it for them, I need Rob so that we can take our information from the simulation environment and put it next to the trended environment. Now I can see in real time, did I get what I paid for?
Yeah. Yeah. Rob?
And Craig, I think you touched on the site energy, which made me think we need to do a little, I'll call it myth busting, right? We talk a little bit about carbon neutrality and net zero. And then we talk about net zero, and site energy usage is just one definition of net zero, and it's gameable. So I think for the audience, Craig, if you could sort of just go down those 4 different types of net zero, so that the audience knows that.
Yeah, it's a great idea. And we can measure all of them from the technology in a building, Rob, as you well know, because we're doing it with you right now, is that the way in which we measure our key performance indicators in buildings, our metrics, is site energy use intensity, source energy use intensity, total costs, and greenhouse gas emissions. And the way it's been done in the past is those can be gamed, right? I can bring in natural gas instead of electric, and it's going to be cheaper, and I reach my total cost goals, but did I really decarbonize my goals? If we're setting our goals, and Jim, this is one of the reasons why at the beginning of the podcast we talked about what's your goal, what are you trying to reach?
Yeah.
If you don't define that, then you have a misalignment in the project team, you have a misalignment in the measurement verification team, and you're going to have some confusion in your team. If you're meeting carbon related goals, then you better be using carbon as your key performance metric and how you define your design, and then ultimately how you put in your measurement verification systems, because it's the only one of the metrics that almost can't be gamed. But the other ones, site, source, cost, pretty much most of those can be gamified to reach those goals without actually reaching the real goal that you want to reach, and that's decarbonization of buildings without sacrificing performance.
Okay. So we're talking, and thanks for that. I think that's a good definition, and we need to start that to ask this question, really, right? Is how realistic is decarbonization of buildings if with some of our older building stock? What are your thoughts on that? I mean, we mentioned this 2%, 1% replacement retrofit figure. I mean, I
think it's absolutely a realistic goal. But go ahead, Rob, for sure.
Yeah, but before we get into the technology conversation, I would say, working with Craig and lots of other big portfolio owners, the challenge is not the technology. The challenge is people understanding what the technology is capable of and desiring to go in the same direction and have the same goal. So the realistic, and Craig can dive into the details here, but the reality is, if the right leadership is in place in an organization that understands all the key stakeholders that are going to have to march in the same direction to decarbonize their buildings, I'm not saying it's easy, but it's not the super hard thing that we're seeing out in the industry right now because of this incrementalism. But go ahead, Craig. I just want to make sure it's people are the challenge.
No, thanks for teeing it up, and I couldn't have said it better myself. I mean, it's a learning curve problem. When we've been doing this long enough now, it's a learning curve issue. You look at places like Brussels. Brussels has codified Passive House, and they have a great presentation. I've seen it at all the major conferences for building performance, and they talk about they almost like misstepped their way into it. Like they made their codes of Passive House about 6-7 years ago, and they just did it, right? Because they knew it was a very high aspirational target, but they didn't know the ramifications. So the first year they had some pushback, and the community said, this is going to cost us money, and all the normal arguments you get from change resistant people. And then fast forward to today. I mean, the industry has changed to address it. The community has learned how to build to these levels of performance without a premium. Equipment, low flow equipment, windows, all of the toys we need to build high performance envelopes exist because of what they did. And in the United States, I mean, I've been doing Passive House level work for 10 years now for large buildings, right? And even 5 years ago, we're buying our windows from Europe because the United States didn't have cost affordable triple pane windows to meet these levels of performance to balance our fenestration. Today, there's probably 20 manufacturers in the United States I can source my windows from. So it's a learning curve. As the community begins to learn how to do this, the architects and the mechanical engineers and electrical and plumbing engineers start to learn how to design to these levels of performance, you're going to start to see cost parity come into play because the learning curve is being achieved. So we don't necessarily think that this is the premium, because I always use this adage that insulation is always cheaper than systems, right? Mm-hmm. When we want to talk sustainability, we're always looking at our mechanical engineers saying, put in better equipment. Well, we want to make that equipment go away or make that equipment much, much smaller, right? So there's a difference there, but that doesn't mean we eliminate the mechanical engineer. They have a great role to play in what we're doing, but it's a learning curve. Respect the natural order of sustainability. Make sure your team is aligned on goals. And then, Jim, we do not believe that there's a premium to reaching these levels of performance, especially in an existing building. If you're respecting triggers, then you're just, it's system replacements, it's deferred maintenance, it's natural renovations, it's any opportunity to touch a building, and then I touch it the right way. I just don't replace it in kind and hope for a better outcome. Okay,
that's important. You're saying to achieve this level of decarbonization, you don't believe that it's, you're paying a premium for that. You shouldn't.
Absolutely not. I don't. And not only that, because of the learning curve, I believe, at least in the United States, through IRA funding and other incentivization programs that exist right now, and there are a lot of them that exist right now to support this, they're there to get us through the learning curve. Mm-hmm. That's what this is all about.
And if I add another thing in our learnings through we're all on a learning curve here through talking with Intelligent Buildings and the Auros Group. When you talk about a data-driven approach, one of the interesting things that the Auros Group has discovered is that we estimate our carbon today in buildings. It's using blended factors and so forth. And one of the exciting things for your audience to know that as they try to achieve their goals, Craig, what you told me, 15% on average, the when you look at the data, is lower than what you've been estimating. So there's a big window of hope here for folks to get a jolt in the arm, if you will, that using the data, we are overcompensating in a call it correction factor when we're estimating that fourth version of net zero, the one about emissions.
Okay.
Yeah, Rob, that's correct. And again, I think it's just another product of where we've been. It was why we're here. When we wanted to measure our building performance, we go and get all of our invoices. Well, guess what? That's 12 points of data a year, which isn't a lot of value. And what we're talking about is if we shift to an hourly accounting with meters and sensors with smart building infrastructure, like Rob is talking about, I can have 8760 points of data a year. That's a big difference from 12. So I can calibrate my model better. I can start talking about the value of storage and load shifting and demand response, because I can't do that math for an ROI based on 12 points of data. 12 points of data doesn't know when peak and off peak occurs because it's 12 points of data, right? It's a monthly figure. But when I can get to hourly accounting opens up the door to really start looking at real value of existing buildings transforming into high performance buildings. And I think that that's key. So Rob, thanks for mentioning that, because I think the work what you and I are doing right now in implementing hourly accounting for carbon automatically through smart building infrastructure, it's the key to unlock the value of existing buildings. And we see value in existing buildings. A lot of people see them and they call them stranded assets, or they see them as these things they never want to touch, like, oh my God, this is terrible. We look at a building with, you're telling me in my language, that building has every trigger I could possibly want to retrofit it. And for us, we're thinking that's the most valuable building that exists right there. That's where we can extract a ton of value out of that.
Yeah.
And for your audience, 8760 is what, Craig?
The number of hours in a year.
Yes. There you go. All right, guys. So I've got one final question to both of you. What is the one thing you want people to take away from this conversation today? Craig?
So the one thing I would like people to take away from this is to know that this work is being done. It's being done cost effectively, and we are now decarbonizing existing buildings. And that is a key to reaching our climate change goals. Like I said, we can't build our way out of this problem. We can't renewable our way out of this problem. We've got to deal with the existing building stock. and we can deal with that existing building stock in a way that we can decarbonize. So I would say, instead of being a naysayer and say, just because I've never done it doesn't mean I can't, look at those buildings that are now being transformed. And I think that's the key. And if we figure out how to do that, then the government, the policy people, the larger corporations have to figure out how to create the incentives to support it and create the right ORIs that are going to support a financial investment in that. Because you talk about load shifting. Load shifting is so critical. We couldn't talk about battery storage in buildings because it, quote unquote, doesn't pencil. But wait a second, if I load shift off of my peak and I'm paying my electric bill on non-peak, then that value of battery storage completely changes. And that has the effect of reducing our marginal carbon because I no longer need to contribute to peak. I can move and shift everything off. So it changes everything. So there are tons of strategies that we can employ. I would always say, respect the natural sustainability, respect passive over active, respect efficiency over active systems. And if you do that, you're going to find your way to reach the goals that you want to set for yourself. So there's definitely a process about doing this, and it's being done now today. So, there's no longer, we no longer accept people saying, you can't do that anymore. We can show them buildings that are doing it all day long.
Great. Rob?
And I would say that we draw the analogy back to lifestyle, and we'll call it the low carbon lifestyle for buildings, right? The low carbon lifestyle for buildings, similar to humans, who you have to have physical health, mental health, and practice a lot of things to have longevity. When you talk about buildings, you need to look at the building science, which Craig has been talking a lot, the data science, which is analogous to your mental health, if you will, and then the resiliency as you move forward. And if you look at it holistically and start with data that is available to you or could be made easily available to you, these primary energy sources that Craig's about, you are headed down a path with a high degree of success and the lowest and highest velocity at the lowest cost. But if you go down a path of incrementalism, you're likely going to hit a lot of brick walls and not get to your goal, which should be net zero carbon emissions. The other three are gameable.
Yep. I think that's a great place to finish. Thanks a lot, guys. We've got some show notes, so I'll make sure I put a link to that in when we put this on our website, and also a link to your book as well, Craig, for sure.
Thank you, Jim.
You're welcome. That. And it just remains me to say thanks everyone for listening, and of course, thanks Rob, thanks Craig. Really appreciate you taking the time.
Thank you so much.
Really appreciate the hospitality. Thank you.
Bye for now.